Hi, today we present our project of the subject design of machines. The group is conformed by Cano, Fonseca, Sebastián, Carreño, Nocove, Nicolas, and Trujillo, Franco, Sergio. This presentation is composed of system description, structure assembly. In this section, we will talk about joints, main joints, and profiles and screws. After loaded videos, advantage and disadvantage, and finally, assembly manual. We start with system description.
Humanity is in a boom of high electrical energy consumption due to overpopulation, but because of this massive energy consumption, natural resources have been exhausted to produce electrical energy, and other problems such as population or irresponsible exploitation. By means of renewable energy system, it is possible to reduce the consumption of territorial natural resources and use energy from other sources without affecting the environment, but making an energy system of this type is not so easy. In this project, a structure was designed and simulated to hold 6 solar panels in such a way that it resists without damage or affecting the generation of electrical energy, using affordable materials and justifying its operation. Aluminum profiles were used for the structure and 3D printed joints that give stability to the design. Real and simulated resistance tests were made to verify the calculation made.
The system consists of 20 support points, 2 rows of 10 support points. In each of the supports, 8 profiles are joined around the main profile to give greater stability and increase rigidity since they are embedded in the ground with cement. The joint support points, horizontal profiles, are located thus have 10 degrees of inclination that allow greater energy efficiency of the solar panel. Additionally, 2 long profiles are located perpendicular to the previous ones. On this, the solar panel will be located and fixed with the help of one of the types of joints designed.
6 solar panels will have placed one next to the other forming a rectangle on the design structure. This allows the location of more support points, reducing the effort that the structure must make, while distributing the weight in a more uniform way. This also allows increasing the stability of the structure and greater security against environmental risks and storms.
Most of the joints are designed to adapt to the groups of the profiles. These were measured with a caliper. The design tolerance for each joint is 0.5 millimeters in such a way that they don't enter in a forced way. The design of articulations to measure precise weight one of the profile is with the objective of avoiding the unnecessary use of screws that increase the weight and in some cases generate instability in the structure. The screws used in this design are clearly necessary since they press the pieces and preventing the profiles and panels from sliding. Now we will see structure assembly. Joints. This joint is a plug for the profiles of the ends of the countertop, in addition to eliminating the exposure of sharp and dangerous edges. It provides supports for the adjustment of the ends of panels 1 and 6. This piece has a lower height than that of the panel to allow its adjustment. 4 units are required and is called cap 1 profile. This joint is called joint 9 profiles and is responsible for keeping together the 9 vertical profiles of each support point of the structure. 20 units are required. This piece is called joint 9-1. It is in charge of joining 9 profiles, limiting the passage of 8 of these, allowing the main profile that will join the horizontal profiles of the structure to pass through. 20 units are required. This joint is a plug for the profiles of the ends of the countertop, in addition to eliminating the exposure of sharp and dangerous edges. It provides supports for the adjustment of the ends of panels 1 and 6. This piece has a lower height than that of the panel to allow its adjustment. 4 units are required and is called cap 1 profile.
This is the fixed gasket of the solar panels. It is called adjustment. In addition to fixing them to the profiles, it guarantees the correct separation of these to avoid the accumulation of thermal energy at the edge. When assembling, it fits into the profile. Then the solar panels are attached and finally the fixed skirt is placed to prevent slipping in the piece. 14 units are required.
We can see how, with this piece, we join 2 profiles, and 2 screws are used to hold it, and 1 more screw to prevent the profiles from sliding out of place. With this joint, we will join the embedment with the profiles, and they will also be fixed with 2 screws with nuts. Like the previous one, the assembly is the same, and we can see how it should be in the loosening of each joint, with respective fastening elements. Our structure has 3 main joints.
This piece is called joint 80 degrees and is responsible for joining the height vertical profile to the horizontal profiles. This joint ensures the 10 degrees of inclination of the horizontal profiles with respect to the horizontal axis. As we observe, the horizontal profile is entered first and then the vertical profile is entered. Then the fixing screws are placed one each profile.
This piece is called joint 100 degrees and is in charge of joining to the lowest vertical profiles to the horizontal profiles. It works with the previous piece to ensure the 10 degrees of inclination. And the order of the assembly is the same as in the 18 degree joint. 10 units of this joint are required.
Here we observe the joint called joint 2 points. At the bottom of this, the horizontal profile enter, and in the upper part enter the profile that supports the solar panels. As can be seen, entering the 2 profiles, fixing screws are placed to ensure that the profiles don't move from their place. The lower profile supports the weight of the upper profile.
Now we will talk about profiles and screws.
Short profile. These are the short profile. They are in charge of giving greater rigidity and stability to the environment of the structure. For this, they are joined around the main profile in each of the support. 160 units required. Short column. This profile is responsible for ensuring the minimum height of 1.2 meters to the solar panels. This height prevents the solar panel from being easily damaged. 10 units required. Long column. This profile is longer than the previous one since it is necessary to ensure 10 degrees of inclination of the horizontal profiles to increase the energy efficiency of the solar panel. 10 units required. Horizontal profiles. These profiles are responsible for joining the vertical support points giving order to the project structure. 20 units are required. And perpendicular profiles. These profiles are responsible for supporting to the solar panel. They are the longest profile of the structure. 2 units are required. To give more stability to the joints made with the profiles, screw nuts and washer are used. No special screw is requested, but they must be placed correctly. The structure is assembled as follows. First, you must put the bases that will be embedded in the ground as shown in the video, made up of 8 profiles and the corresponding joints. The structure begins the form with the 2 longs profile, embedding them in the previous pieces. The 180 degrees joints are placed as shown in the video. The screw, washer and nut must be placed to secure the piece correctly. This procedure must be carried out with the both pieces. In addition, the profile that can be seen on the screen must be built, placing the respective joints in the profile and adjusting them with screw, nut, and washers. This already assembled profile must be inserted through the 2 points of 10 and 8 degrees. The profile must be correctly adjusted to these joints with a screw, washer and nuts. Afterwards, the long perpendicular profiles must be inserted. The respective caps must be placed at the ends and correctly tightened with screws, washer and nuts. It is time to place the solar panels. These must be adjusted with the respective union. The panels must be tightened without damage them, but also without leaving them loose. In this way we will finish our assemble. It is a time to enjoy renewable electric energy with a reliable structure.
Next, we will observe the load test videos, simulations, and real tests.
The structure was simulated with the approximate loads that the panels will make on the profiles. It is a load of 240 newtons, uniformly distributed, represented by the rows. Apart from that, the points where the joints will go, represented in the pink points. Finally, were determined the fixed support that the structure will have been determined, represented by green points. Considering that the material of the structure is aluminum, the simulation results were as follows. The structure withstand a maximum pressure of 60 megapascals. The structure is reached to the form 11.4 millimeters, and it has a safety factor of 2.4, which indicates that the structure is adequate. The simulated tests were made considering the height of the panels, so it was simulated with a load of 253 newtons where the panel rests. It was fixed where there is no movement, and the pressure of the screw was considered. For the joints to points, It was simulated like this on the screen. The profile moved approximately 0.4 millimeters. Here you see the greatest effort, and here you see the greatest street generate. For the joint 80 degrees, it was simulated like this on the screen. The profile moved approximately 1.5 millimeters. Here you can see the greatest street generate and the greatest effort. For the joint 100 degrees, it was simulated like this on the screen. The profiles move approximately 2.3 millimeters. Here you see the greatest effort and here the greatest street.
For the actual test, assembly was first performed of each joint. We first join the profiles with the joints, and then they were drilled. Subsequently, their respective screws and nuts were put in place. For the required weight, according to the simulation, are 250 newtons, which is equivalent to 25.9 kilograms, which was made with bricks and other heavy materials. For joint testing, a screw-free test was first performed, where the force was applied as in the simulation by means of a rope. And here we can observe the displacement of the profile. Once the displacement is measured, we see approximately 2 millimeters, which is very close to that of the simulation. For the joint 18, the same tests were carried out, but with the screens and support correctly. Here we can better observe the displacement of the profile with and without weight. Here we see the displacement which was measured with the ruler. An approximated value of 2 millimeters was obtained, a value that is very close to that of the simulation. Finally, the burden was placed on the joint point with two equal forces. Here we can see that practically nothing is moved, and this comparing with the simulation, we can see that a value close to 0 must be moved. And here it was finally done in a final assembly. And that's how it will look on a small scale.
What are the advantages and disadvantages of our design?
Advantage: it is a renewable energy, easy to assemble structure, totally firm recess, easy replacement of the joints since they can be imprinted in 3D as many times as necessary, a structure designed to resist not only the height of the solar panels but a little more. The system is secured by screws. Disadvantage: PLA is biodegradable, so the system structure cannot be for a long time system. An anti-corrosive should be applied, this to increase the service life to the aluminum profiles. Cost: This because the overall structure with the solar panel is quite large and can cost a lot of money tilt angle. Designed with a specific tilt angle depending on the solar incidence of Shia Cundinamarca. It is not adaptable because it can only be located on the ground with concrete.
And finally, we will see the explanation of the assembly manual of our structure.
Next, we will see the manual of the structure. First, we can see the table of content. Later, we observe the bill of materials with its corresponding number. This must be checked with the plans and with the quantity on material of each piece. Then we can see the description of the embedding, and with the numbers that we can see here, we identify each of the joints. A small image of how it should be assembled is shown, and the necessary amount of reset is described. Then we proceed to assembly of the structure. First, we show the tools that are going to be used. Then we show the first section that must be assembled with the description of each piece used. The true once the pieces are identified, it is quite intuitive to carry out the assembly. The amount of the semi-structures necessary for the entire structure is also described. Then all these semi-structures are joined with two long profiles called profile cross-section 2 and joined with the piece called joint to points. With what the second semi-structure is obtained. Later, a space is left to take notes. Later, we go to the description of each joint, and as they are going to be fixed by means of scripts, there are three joints. Later, the process to fix the panels to the structure with the joint called adjustment is shown and show how it will be fixed. Finally, we see a cap for aesthetics and safety of the spouse profiles. Here we show an image of how the final structure should look and some general recommendations to follow for the correct ensemble. And here more notes, and here the end.
This is our solar panel structure. We appreciate your attention.